Hello, it's me again, and welcome to a new video. We are continuing with calculus, and we are still in chapter 1, hopefully finishing it today. And I now realize I don't have my watch nor my jewelry on me, but I hope it doesn't bother you. I think we were left at, we finished problem 19, so now we must do problem 20. And in fact there's this short paragraph about the next problems. And it reads, in our later work, 3 facts about inequalities will be crucial. Although proofs will be supplied at the appropriate points in the text, a personal assault on these problems is infinitely more enlightening than a perusal of a completely worked out proof. The statements of these propositions involve some weird numbers, but their basic message is very simple. If x is close enough to x0 and y is close enough to y0, then x plus y will be close to x0 plus y0, and xy will be close to x0, y0, and 1 over y will be close to 1 over y0. The symbol epsilon, which appears in these propositions, is the 5th letter of the Greek alphabet, and could just as well be replaced by a less intimidating Roman letter. However, tradition has made the use of epsilon almost sacrosanct in the context to which these theorems apply. Wow, I think I learned about 3 new English words from that paragraph alone. Sacrosanct, perusal, okay, 2. But hey, let's check out these problems. And, well, just a side note that those of you who are already familiar with calculus might already guess that these will be related to it very intimately, because in calculus we are often concerned with these arbitrarily close small differences between 2 numbers. So, number 20. Prove that if absolute value of x minus x0 is less than epsilon over 2, and absolute value of y minus y0 is less than epsilon over 2, then these 2 statements are true. Okay. So basically, if x is close to x0 and y is close to y0, then x plus y minus x0 plus y0 should be close to epsilon as well. This should be close as well, as Spivak said in the paragraph. So let me just pull up my notebook. Oh, and I should say, in the last video I made a mistake. I said that a squared over 4 taking the square root does not create 2 solutions because of this. But that's obviously false, because we should have a minus here and a minus here. So I was just wrong. I just wanted to mention that. And also worth mentioning is I bought these more colorful pens, so I might use those sometimes to make my solutions more visually pleasing. But I'll stick to the black gel though, it's my favorite. Not any sponsorship, but I can really recommend these Japanese gel pens. They just are so smooth and I love them. My life changed when I found these. But okay, to the problem now. So absolute value of x, sorry, you can't see. Absolute value of x minus x0 less than epsilon over 2. Yep. And absolute value of y minus y0 less than epsilon over 2. So if we just kind of remove these absolute value signs, we get negative epsilon over 2 is less than x minus x0. And similarly for the y. And then we can just add these two expressions together. It's quite obvious that it maintains, that it like works. So we just add them together like this. And then we can combine in the middle like this. We get x plus y minus x0 plus y0. And then we just put it back to absolute value form. Like this. And that is what we desired. So QED. So quite easily we can prove that if x and y are close to x0 and y0 respectively, then, well, x plus y is close to x0, y0. x0 plus y0. And well, I'm pretty sure this can be done quite similarly. But you can maybe try doing that at home. So we just move on to problem 21, which is marked with a star, so it might be quite hard. And well, I've done this and it is quite hard. But let's not get too intimidated by the star. We can do it. So prove that if x minus x0 is less than minimum of epsilon over 2 times absolute value of y0 plus 1, comma 1, and this statement, then xy minus x0 y0 is less than epsilon. And also Spivak mentions here that you might remember that we had the formula for the minimum earlier, but it's of no use here. And okay, how should we approach this? Well, we can see that first of all x minus x0 is less than 1, and x minus x0 should be quite close to, is also less than epsilon over 2 times y0 plus 1. And a very similar formula or equation on inequality on the right. So somehow x and x0 are close and y0 are close. And now we need to show that xy is close to x0, y0. And well, let's just start by typing. So we had x minus x0 less than epsilon over 2 times y0 plus 1. And well, let's multiply by 2 and also expand this to take the absolute values out. So then it's epsilon over y0 plus 1 less than 2 times x minus x0 less than epsilon. This should be negative epsilon, sorry. Epsilon over 2 y0 plus 1, like that. So again, we just remove the absolute values to make our life easier. But what should we do next? It seems a bit hard. Somehow we need to get this kind of expression containing xy and x0, y0. So perhaps we should try writing down some expression. So let's say we have xy minus x0, y0. How could we express this in terms of these two? Well, this happens to be equal to x times y minus y0 plus y0 times x minus x0. So let's just remember this. And then on this one, let's multiply everything by y0 plus 1. And also divide by 2 again. So let's like this. I realized that multiplying by 2 here wasn't the greatest idea. I'll show you later why that was. So let's just do this. And it doesn't matter whether y0 plus 1 is positive or negative, because this is symmetrical. So if the inequality signs is flipped, nothing would have changed. So we have negative epsilon over 2 less than x minus x0 times y0 plus 1 less than epsilon over 2. Yep. And we can you can't see it. So now we found out that negative epsilon over 2 less than x minus x0 times y0 plus 1 less than epsilon over 2, or like between those two. And we can get a similar expression for y, which would be like this: y minus y0 x0 plus 1 epsilon over 2. And well, if we sum these two together, we get x minus x0 times y0 plus 1 plus y minus y0 times x0 plus 1. Right? Yeah. Less than epsilon. And this is equivalent to, if we just rearrange a bit, or open the multiply the brackets open, it's y0 times x minus x0 plus x minus x0 plus x0 times y minus y0 plus y minus y0 less than epsilon. And well, this expression is already part of what we want, and this one is almost, we just wish that the x0 was x. But let's first put this into the absolute value form. So absolute value of y0 times x minus x0 plus x minus x0 plus x0 times y minus y0 plus y minus y0 is less than epsilon. And now, okay, we were given that x minus x0 absolute value is less than minimum of these two. So thus x minus x0 is also less than 1. So absolute value of x minus x0 is less than 1. Which is the same as this. And I'm now thinking how was it that I did this? Let me look at my notes real quick. Okay. So in fact we can add like absolute values also. In here and in here between all of these. So it would be like this and like this and like this and like we would have additional absolute values like that. Sorry, this is so confusing right now. I'm doing a bad job explaining this because I'm not understanding this well enough myself either. Let's try adding x0 to both sides. basic idea was that we would get that absolute value of x is less than 1 plus absolute value of x 0, like that. And then in here we can we get this type of chain that because x is less than 1 plus x 0, which was, so for example here we have 1 plus x 0, we can change this to x, and that x, I'll open a new page so I can write it more clearly. So we have that absolute value of y minus y0 times x0 plus 1 plus x minus x0 times absolute value of y0 plus 1 is less than epsilon. Oh, sorry, okay, here it is. Sorry, you didn't see it there. And no, because absolute value of x is less than absolute value of x0 plus 1. We then have that less than this expression. This expression up here is greater than the expression where we change x0 plus 1 to x, just x. I'm doing a poor job writing out too. And obviously because this absolute value f x minus x0 is positive, so if we take this from, and here we have times y0 plus 1, so if we take this 1 away, then this obviously is also smaller, because that also makes it less. And thus we find that absolute value of y minus y0 times x plus x minus x0 times y0 is less than epsilon. And so yx minus y0x plus y0x minus x0 y0 less than epsilon. These cancel out, and thus we are left with yx minus x0 y0 less than epsilon, which is what we wanted here. And well, in my proof, okay, I skipped over some details. I did some kind of illegal stuff. So this is not valid proof, but that's the basic outline. And because I didn't write my notes well enough, and I don't want to spend too much time on focusing on this one problem, this is what I can show you now. But I recommend drawing at home, making this argument more rigorous by completing the missing steps. But yeah, sorry about that. Let's now move on to 22. Prove that if y0 is not equal to 0 and absolute value of y minus y0 is less than this expression, then y0 is not equal to 0 and 1 over y minus 1 over y0 is less than epsilon. Okay, so essentially what this is saying is that if y and y0 are close, then also 1 over y minus 1 over y0 are close. So let's first start by showing that y is not equal to 0. We were given that y0 is not equal to 0 and this is less than min of absolute value of y over 2, absolute value of y0 over 2, and epsilon times absolute value of y0 squared over 2. So let's first try to show that y is not equal to 0. And well, we are given that y minus y0 is less than absolute value of y0 over 2. And let's assume y is equal to 0, then negative absolute value, then this would have to be true, which would say that absolute value of y0 is less than absolute value of y0 over 2, which is obviously false because these both are positive. So dividing by y over this 1 over 2 would mean that 1 is less than 1 over 2, which is obviously false. And thus our assumption that y is equal to 0 is wrong, and thus y is not equal to 0. Okay. Then we want to show that absolute value of 1 over y minus this is less than epsilon. And But yeah, so we have that this is basically what we want. We want to show that y0 minus y over y times y0 is less than epsilon. And well, we were given that y minus y0 is less than epsilon times y0 squared over 2. And basically what we need is to show that absolute value of y is greater than absolute value of y0 over 2, because if that is true, then we can do the following. So we have y0 minus y over y times y0, and if this is true, then we can say that this is less than y0 minus y over absolute value of y0 over 2 times y0. Which is equal to absolute value of y0 minus y over absolute value of y0 squared over 2. And then we can use this. Basically we just we have the y0 minus y here, and we substitute it with this. Because, well, it doesn't matter if it's y0 minus y or y minus y0, because it's an absolute value. And because this is less than this, then when we substitute this here, it's greater. So it's epsilon, absolute value of y0 squared over 2 over and well, these cancel out, so it's equal to, well, epsilon. Yeah, so we just need to show that y, absolute value of y, is greater than absolute value of y0 over 2. And well, let's do that. We know that absolute value of y0 is equal to y0 minus y plus y. Sure. minus y plus absolute value of y. Which is equal to, well, y minus. Sorry, there's a small insect flying next to the mic. But we just flipped the minus signs here. And then, thus, we find that y is greater or equal to y0 minus y minus y0. And well, this is greater than y0 minus absolute value of y0 over 2, because that was given here. And this is equal to absolute value of y0 over 2. And thus, because we've proven this, and because this fact implies this, then we have proven the whole thing, namely that given this, we have this. Just making clear, because this was equal to this. So again, we just show that if y and y0 are close, then 1 over y minus 1 over y0 are also quite close. Now, problem 23 kind of combines problems 22 and 21. It says, replace the question marks in the following statement by expressions involving epsilon x0, y0, so that the conclusion will be true. If y0 is not equal to 0 and jin, then y is not equal to 0, and absolute value of x over y minus x0 over y0 is less than epsilon. And Spivak says here, this problem is trivial in the sense that its solution follows from problems 21 and 22 with almost no work at all. Notice that x over y is equal to x times 1 over y. The crucial point is not to become confused. Decide which of the two problems should be used first, and don't panic if your answer looks unlikely. So, what we were given in problem 21, we proved that if these facts are true, then xy minus x0 y0 is less than epsilon. And here that well, this is what you just proved about the y and y0. And well, I'll move you a bit upwards. y0. So as you can see, well, somehow we want to combine the two previous problems in a desirable way. So what should we choose for x minus x0 to be less than or equal to be less than 2? Well, as Spivak said, x over y is equal to x times 1 over y. And here we had x times y and x0 times y0. So we'll use the same inequality, but instead of y0 we use 1 over y0. So we choose that x minus x0 is less than min of epsilon over 2 times 1 over y0 plus 1 and 1. So this is the exact same thing as here, but we just use 1 over y0 because it's what 1 over y0 is relevant in the problem. And then we need to come up with a inequality for y minus y0 as well. And surely we'll use something similar to that of 22, but it has to have something additional in it. And well, what we want is for absolute value of y minus absolute value of y0 be less than epsilon over 2 times absolute value of x0 plus 1, because it's what we have here. It's what we had here, which allowed us to get this. But now we are using y and y0. Instead of y and y0, we use 1 over y and 1 over y0. And so 1 over y minus 1 over y0 is less than this. So with these two equations already, we are able to get this fact. But instead of using 1 over y minus 1 over y0, Spivak wants us to write it in terms of y and y0. But to get that easily from this, we just, instead of using epsilon, use epsilon over 2 times absolute value of x0 plus 1. And thus 1 over y0 is less than minimum of, well, the initial first one stays the same, y over y0 over 2, but the second one is well, instead of epsilon here, we have epsilon over 2 times x0 plus 1, so we just put that there, getting epsilon times y0 squared over 4 times absolute value of x0 plus 1. So basically, we used problem 2021, but instead of using, we kind of used 1 over y and 1 over y0 in as y and y0, and then we just had to transform the 1 over y minus 1 over y0 into this y minus y0, and that was done using problem 22, like this. So in the end, it was very hard for me to come up with this, but as Spivak says, this problem is trivial in the sense that its solution follows from problems 21 and 22 with almost no work at all. So that's that. I feel like I did a very poor job explaining my solutions now, but I think I still conveyed the basic idea, and you can, maybe it's also healthy to try and fill in the details by yourself, so you have to actively think of it. Problem 24 is then very different from, well, these problems we've been doing now. This problem shows that the actual placement of parentheses in a sum is irrelevant. The proofs involve mathematical induction. If you are not familiar with such proofs, but still want to tackle this problem, it can be saved until after chapter 2, where proofs by induction are explained. And well, I know induction, but maybe not all of you know induction, so I think we should leave this for after chapter 2 and do it then. And the last problem in chapter 1 is problem 25, and it says, suppose that we interpret numbers to mean either 0 or 1, and plus and multiplication be the operations defined by the following tables. Check that properties P1 to P9 all hold, even though 1 plus 1 is equal to 0. And well, I will not do that. If you want to do just zeros and ones, so it's you can think of this as I haven't studied too much abstract algebra, but I think it's called a ring of numbers. Basically, it's a ring. Its numbers mod 2. So, if you know modular arithmetic, this might make sense. And that's why 1 plus 1 is 0. And well, I think this is a ring. I'm not 100% sure, but I think. And rings, I guess, then have properties 1 through 9. And then you could have maybe, I guess that's the simplest type of example. But then you could have also like mod 3. So then you would have 0, 1 and 2. And then 1 plus 2 would be equal to 0. Because whenever we go over a 3, we subtract whenever we well, yeah, that's how it works. If you understand modular arithmetic, you will understand this. If you don't know modular arithmetic, Google it and then you will understand this. But hey, now we are done with chapter 1. And next we will start with chapter 2. Numbers of various sorts. But that will be for the next video. For now, thank you very much for watching. I'll see you in the next video.